we've got a 2.63 grams of sodium hydroxide lye. This is what you use to make soap. And we dissolve it in 156 milliliters of solution. And then we want to determine the NOH concentration and the pH. So this problem will have both in it. Has both calculate molarity, and then it also wants you to calculate pH. The problems on the final are one or the other usually, but it's good to practice both. So we have some sodium hydroxide, some lye, got 2.6 grams of it. We're dissolving it in 156 milliliters of solution. We want to figure out the concentration, the molarity, and the pH. So our first step is we need to figure out the molarity. To figure out the molarity, we need to take that mass of sodium hydroxide and convert it to moles. And the way we convert to moles, what we want goes on top, moles on top. And then we need the molarity, or the molar mass of sodium hydroxide. All we got to do to get that is go to the periodic table. So first off, we've got sodium. I'm going to switch over to the periodic table. So if I've got grams and I want to get moles, I go to my periodic table. Which is not loading, okay. So I'll just go old-fashioned paper. I go to my periodic table. I find on it sodium. Sodium has a molar mass of 22.99. It's just the big number at the bottom of the square. Then I find oxygen. There we go. So I find oxygen on the periodic table. I look at it. I see 15.999. So I just get these numbers from the periodic table. Then hydrogen, last of all, 1.008. And this is all in grams. So we're going from grams to moles. We start out with the given. It gave us the number of grams. We're going to convert it to moles by taking the molar mass, adding up everything on the periodic table. I'm going to add those all together on the calculator. I get 39.997 grams as my molar mass, just adding up everything that's on the periodic table, adding up my Na, my sodium, my O, my oxygen, my hydrogen, just adding them all up together, getting a molar mass. Then I take the top 2.63 grams, divide by the bottom 39.997. And so that tells me I have 0.66 moles of sodium hydroxide. We want the molarity, which is the concentration. So molarity equals moles per liter. Now the problem gave me it in milliliters. That's fine. I just need to divide by 1,000. And so I'll get 0.156 liters on bottom, just dividing by 1,000, dividing by liters. And then that moles goes on top, 0.66 or 0.066 moles. Molarity is moles per liter. Molarity is moles per liter. I divide 0.066 divided by 0.156. And I get 0.42 molar. So that is my concentration of NaOH. Concentration always means molarity. So that's my concentration of NaOH, my molarity of NaOH. And then the second step asks me for the pH. This is where we have to think for a minute. pH is based on free hydrogen. pH is based on free hydrogen ions. This has OH. This is a base. I have the molarity, I have the concentration of OH. So it's like the third column on the worksheet. This is my OH, because it says NaOH. So I can actually find POH, not pH with it. Since it says OH, I can find POH. If it just said H, it'd be an acid, and I could find pH pretty easily. But since it's a base, the concentration is 0.42. I take the negative log. I'm getting POH. I take the negative log of 0.42. I take the log of 0.42. I get a POH of 0.38. POH because it's NaOH. But the problem doesn't ask me for POH. It asks me for pH. It asks me for pH. So my very last step to find pH, if I have POH, well, pH equals 14 minus POH. So pH is going to equal 14 minus 0.38. And so I get a pH of 13.62. Is that an acid or a base? Base. It's bigger than 7, so it's a base. Bigger than 7 is a base. So I found my concentration. When I see concentration, that means molarity. I found my pH. I found my POH, and then I used my POH to find my pH. So this is a multiple step problem. It's a little more complicated. Start with a hard one. Okay. Let's look at a couple more. What is the pH and POH of a 1.2 times 10 to the negative 3 hydrogen bromide solution? And so the tricky part is figuring out whether we've got H plus or OH minus. We got H all by itself, so this is going to be an H plus. So we'll find pH first. This is an H plus, since it's just got an H. So H plus equals 1 times 2 times 10 to the negative 3. So pH equals negative log of 1.2 times 10 to the negative 3. So I found pH. First I got H plus. H plus is given to me in the problem. I know it's H plus because it's hydrogen bromide. It's not got an OH in it, so it's going to be pH. Negative log 1.2 times 10 to the negative 3. Type that in my calculator, I get 2.9. So that's the pH. All I got to do is type that in my calculator. And then for POH equals 14 minus pH. So it equals 14 minus 2.9. Minus 2.9. So it equals 11.1. Is this an acid or a base? Acid. It's an acid. POH is bigger than 7, but pH is less than 7. pH, we look at pH, we don't look at POH. It's an acid if it's less than 7. If pH is less than 7. POH works the opposite, so don't look at POH, just look at pH. The POH, or pH. It's less than 7. Okay. What is the pH and POH of a 2.34 times 10 to the negative 5 sodium hydroxide solution. What is the pH and pOH of a 2.34 times 10 to the negative 5 molar sodium hydroxide solution? So this one, since it's sodium hydroxide, it's got an OH. This is OH. So when I take the negative log of this, that's going to give me POH. OH goes with POH. OH goes with POH. So whenever I solve this problem, first step, I'm going to find POH. POH equals negative log of OH. POH equals negative log of 2.34 times 10 to the negative 5th. Type that in my calculator. And I get a POH of 4.63. POH of 4.63. And so next step, this is POH. I want to find pH. pH equals 14 minus POH. So it equals 14 minus 4.63. So I get 9.37. Looking at the pH, is this an acid or a base? Looking at the pH. Look at the pH. It's a base. Do not look at POH. POH is the opposite. POH is always the opposite. Okay.